I'm Jackie Faherty from the American Museum of Natural History. Let's answer your questions from the internet. This is Cosmology Support. Eagle Jomer asks, hey Siri, how old is the universe? The universe is roughly 14 billion years old. And we get to that answer by looking out into the cosmos and seeing the most distant things that we can. The most distant thing in the observable universe is the cosmic microwave background radiation. That's the signal of the Big Bang. And right behind me, we have a representation of what the cosmic microwave background radiation looks like. Bluer colors or redder colors showing tiny temperature fluctuations for what might have been going on about 13.8 billion years ago. At Purposefully Lit asks, so did we decide if 3I Atlas is a comet or an alien ship at this point? I'm trying to see if I need to get my life together. You need to get your life together. It's just a comet. It's not an alien ship. 3I Atlas is one of 3 objects that were discovered that have a velocity that suggests that they are not gravitationally bound to the sun. They didn't come from the leftover material that is in our solar system, which is where the majority of our comets come from. The first one was Oumuamua. The second one is called Borisov, and then there's 3I Atlas. Oumuamua came in and had a composition that was most like what we would call an asteroid. Borisov grew a tail like we would usually see happen with comets as they get close to the sun. They're icier, so you see a nice beautiful tail as they get hotter and closer to the sun. 3I Atlas arrived, and all the imagery that we've seen thus far indicates that it's got a tail like a comet. So 3I Atlas is still a really exciting object, even if it isn't the alien ship that's gonna take everybody to a different place. 3I Atlas is an object formed out of the material from another solar system. At M5 Defense asks, is the universe infinite? In an infinite universe, it's infinite in all directions. Lines of light stay parallel forever, what we refer to as a flat universe. In a finite universe, the structure would have to curve back on itself. So it could be a curved structure, like a spherical structure, or it could be open on either sides, like a saddle. Studying the shape of the universe is a major aspect of astrophysical research. All we're really referring to in this case is how light, as it's moving, is moving either parallel or it's curved. So our current thinking now suggests that we live in an infinite universe. At TBG3963 asks, are we living in a multiverse? Yes or no? I can't answer that yes or no because nobody knows. Is it possible? There's nothing I can tell you that says that it is impossible. So if you could, for instance, get to a point where you saw our universe from a bird's eye view, could you see other universes out there that had their own big bangs that started them? That is a possibility and one that scientists look into. That's not answering the question though, if we live in a parallel universe where there's multiple versions of every scenario of every day you've ever lived. This is simply, are we the only universe that is, or is it possible that there are many out there? And the answer to that question is maybe. Okay, I'm Irish says, in Interstellar, why didn't approaching the black hole cause spaghettification? Spaghettification is the idea that as you get closer and closer to something that's very, very massive, the part of you that's approaching it gets yanked with a force so big that it starts to pull you apart. And if you've watched the movie Interstellar, Matthew McConaughey's character enters the event horizon. The event horizon is the point of no return. You have to get closer and closer and closer to the singularity or the center of that supermassive black hole. And because it's 100 million solar masses, he has to get way closer to the center of the singularity before he feels that spaghettification. Doesn't mean he would have been feeling something, he would have been feeling something, but he wouldn't have been spaghettified. Just remember the difference between a supermassive black hole versus a stellar mass black hole. Very different gravitational pulls on your body. Voodoo Mikava asks, what's at the center of the Milky Way? A supermassive black hole, which we call Sagittarius A star. Also at the center of our galaxy, there's gas and there's some dust. I think of it like Metropolis or Times Square. It's where a lot of material is congregating, but all of it is kind of surrounding this supermassive black hole. OMBX from Reddit asks, what came first, stars or galaxies? The short answer is stars will come first. Stars are the components of galaxies. The first stars, because they were basically just hydrogen, were really large objects, probably 100 times the mass of our own sun. And those didn't live for very long because they're so massive. And so as they blew up, they created the next generation of materials that could come together to make more stars. And as more stars formed, they clumped together, and those clumps, as they came together, formed galaxies. And the galaxies then formed together, and they make galaxy clusters, and all of it comes together to make the cosmic web that we know and love and live in today. Bradley Marquez asks, what is the largest single structure discovered in the universe? The largest structures that we know of are roughly 1 billion light years across. And what they are these gigantic walls of galaxies. So the image that's behind me is from a map that's been made of the Sloan Digital Sky Survey Galaxies. It's a telescope that was in the United States. And it measured how far away all the galaxies are. It's color-coded by their density. And there are some structures that we can tell are all linked together, where the galaxies are all held together into a coherent structure. And we call it the Sloan Great Wall. And for many years, that was the largest structure. But now there's a couple of others that are in competition for it. They each stretch 1 billion light years across. The Milky Way is a part of its own structure, and we call that Laniakea. Astronomers have looked at that structure and seen a couple of things. One, it kind of looks like a spider web with filaments that are coming in and weaving around. Those filaments are made of galaxies. And then in the gaps between them, you can see there's voids. Much of this is being shaped by dark matter. So this web, this structure, which is the hierarchical map of the universe, is carved out by material that we can't even see. DJ Annam wants to know, what exactly is dark energy and dark matter? When you look out across the cosmos, you see the galaxies clump together. But in studying the way everything moved, we realized the stars in the galaxy were orbiting in a way we did not fully understand. Ones on the outside were moving faster than we thought they should be. Same thing with galaxies. Huge clusters of galaxies were being held together, seemingly by nothing, some gravitational thing that was giving off no light whatsoever. And we dubbed it dark matter. Dark matter has the same gravitational properties that you and I have, but it gives off no light, so we cannot see it. And one other thing we discovered is that the universe has been expanding. And not only has it been getting larger, it's getting larger faster and faster. And we weren't sure what to make of that either. But when we realized that the most distant galaxies are way farther away than we thought they should be, we had to give a name to that, to this mysterious force that was driving our accelerating, expanding universe. And that has been called dark energy. So between those two, dark matter and dark energy, they make up roughly 95% of the mass budget of the whole universe. Here's a question from the astronomy subreddit. How do you think the universe will end? The universe is expanding, and it's accelerating as it's expanding. So things are moving farther away from each other. If you wait long enough, everything gets farther and farther and farther away from each other. New stars can't form. The stars that are there will just peter out, which means the heat, what we call the entropy of the galaxy, will just start to slowly dissipate farther and farther down. And it just becomes a frozen, dark, cold world where you can't see anything. That is one and maybe the most likely scenario, called the heat death or the big freeze. In an alteration of that, this same dark energy accelerates the expansion, pushing things farther and farther and farther away, even to the interiors of things. Galaxies themselves pushed apart from each other. All the gas, all the molecules, the protons, the neutrons, the quarks, it all gets decimated and eviscerated by this force. We call that the Big Rip. And then the third option is that the volume of space hits the boundary, that there is some point where we accelerate out and that gravity takes us back in. And when it does, the universe shrinks back down to a singularity point. And that singularity would be the end of the universe. And we call that the Big Crunch. While all of these are scenarios that are going to take the universe out, you do not have to worry about this right now. Each one of these is trillions and trillions, a Google number of years in the distant, distant, distant future. I'd be way more worried about taking care of our own planet right now than how the universe is going to take out the universe later. Blue-haired hero asks, how do asteroid belts stay a belt? Wouldn't gravity pull the asteroids together? Great question. I'm gonna answer that with a little show and tell here. In front of me, you might mistake them for just general rocks, but they're rocks from space. I have one here that is from a collision that's called Allende, and I have a second one from a fall that happened in Kansas. Both of these are from asteroids. The asteroid belt exists in a location between Jupiter and Mars, as shown in the image behind me with all of the green dots that are out there. This belt is not very dense. It was probably a planet that wanted to form, maybe Mars-sized or smaller than Mars-sized, but it's close to Jupiter. Believe it or not, but you could fit the entirety of all the other mass in the solar system aside from the sun inside of Jupiter. Jupiter has a very large gravitational pull. As a result, it wouldn't let a planet form in that vicinity. It would just gravitationally pull it apart. But every single movie you've probably ever seen that shows a spacefaring person traveling around an asteroid belt has done it incorrectly. You're not gonna dodge and weave all of these rocks surrounding a belt. There's huge gaps. You can pass one of these rocks and not see another one for a significant amount of time. Writing Consistent 834 asks, if an alien with a very, very strong telescope looked at the Earth from 1 million light years away, would they be seeing how the Earth looked then? Meaning how it looked a million years ago. And the answer is yes. Behind me, there's an image of the Milky Way with a grid around it that is 1 million light years in radius. And if there was a planet at the edge of any of that was looking towards us, you would see the Earth in an ice age. You wouldn't see technology. You would see megafauna. If you were to go 66 million light years even farther away, a giant asteroid would be hitting the planet as dinosaurs were having their last big moments. This applies even in our own solar system. We're a little over 7 light minutes away from the sun. So it would take us a little over 7 minutes to know that something had happened, because it takes time for the light to leave the object and arrive at your position. At Two Wells asks, why are sunspots black? Sunspots are black because they represent a slightly cooler temperature on the surface of the sun. So the sun is very magnetically active, and sometimes it, for lack of a better expression, it burps. When it does, it's spitting out some material, and the surface might be representative of a strong area of magnetic fields. And it doesn't have as much convection or the ability for heat to leave the sun, which is why it looks to be a darker color. And the sun does go through a cycle where you see lots of sunspots to way less sunspots. When you get more sunspots, you also get more of these burps, where more material will leave the sun, come towards the Earth, and we can have geomagnetic storms that cause fun things like the aurora borealis. Here's a question from the No Stupid Questions subreddit. Would a solar flare destroy the internet? The answer to that's probably a little bit complicated. It wouldn't destroy the internet. It's hard to destroy the internet, but it could cause quite a bit of technological damage. It's a very active star, and sometimes it has coronal mass ejections that come off of it. What we're showing you is a big one. It was called Bastille Day, and it sent a whopping amount of charged particles towards the Earth. The Earth, though, has a very protective boundary, which is this blue magnetic field that you can see surrounding the Earth, and that helps us a lot. Our magnetic field ends up cascading the plasma down across the Earth, centered at the poles, which is why you can get these gorgeous light shows closer to the northern or southern latitudes. Also, this energy that comes from the sun that interacts with our planet can overpower a grid or can actually hit some of the satellites that are orbiting the Earth. What we do now is we turn the satellites off when we suspect that there's a major magnetic storm happening. I am EDAC asks, what is the difference between dwarf planets and other planets? Is it just size or are there other factors? The dwarf planet definition came in the early 2000s when astronomers voted on a new definition for the word planet. And the object that really made everybody vote on it is Pluto. So the difference between a planet and a dwarf planet is, are you dominating your area or not? Jupiter, for instance, it's got an asteroid belt around it. It's got nearly 100 moons around it. Jupiter is dominating its area of the solar system. Pluto just doesn't do that in its area. And so for that, it got demoted to dwarf planet status. Another clear quirk about Pluto is you can see all of the other orbits of the main planets of the solar system. They really form a plane, a nice plane with a little bit of deviation, but a nice plane around the sun itself. But Pluto's off by tens of degrees from the orbit of all of the others. And so as it goes around, it looks like it's off kilter from the rest of the solar system. So that was always a striking quality of Pluto that made people feel a little less comfortable with calling Pluto a planet versus this new designation for it, which is a dwarf planet. Noble Pups asks, what would happen if two stars merged together? It's not that easy to get it to happen. Gravity is more interested in getting the objects to orbit each other. Small stars can do it, and it can be a nice merger, an interesting little explosion. It will be an explosion. The bigger the star or the more massive the objects that are merging, the event gets crazier and crazier. You can get, for instance, two high mass stars to slam into each other. And when they do, they give off an enormous amount of energy, so much so that you might get what's called a gamma ray burst, which is the most energetic kind of explosion that we see throughout the universe. And famously, we saw two neutron stars merge with each other, and the result was a wobble in the entirety of space-time that we could detect from here on Earth. At Rachel in Canada asks, wait, there are rogue planets now? Yes, or at least there's a word that we use to describe objects that are really low mass, wandering the cosmos by themselves without a host star. Maybe they got ejected from their home planetary system. Maybe they formed that way on their own. But what we know is that there's Jupiter-like planets that are wandering around. The image behind me is showing the night sky, but then we can actually show you with these blue circles the locations of stars where we've found planets around them. But then some of those blue circles are going to be surrounding nothing because they are freely wandering dots in the sky that are rogue worlds. We actually think right now every star has at least one planet, if not more. So finding planets is commonplace. How common rogue planets are is an open question in astronomy right now. DW Red asks, is there any possibility of having non-spherical planets out there? By definition, by how the International Astronomical Union defines them, need to be round. You can be a little bit oblate, meaning pulled apart a little bit on the sides, but for the most part, by our definition, you're supposed to be round. There's a lot of objects out there in the solar system that aren't round. Here is an image for you to see, is called Bennu. Bennu is an asteroid. We've actually gone to Bennu, landed on it, taken a sample, and brought it back. But you can see it's quite an irregular shape when you go up to it. It looks like it's a conglomeration of a lot of rocks that have slammed into each other. Those kinds of structures we see throughout the asteroid belt. You can see them even in tiny moons like the moons of Mars, which are called Phobos and Deimos. But for a planet to be called a planet, you need it to be round. At the Physics Memes asks, is there a spot where the Big Bang happened? Do we know where it is? Is it the center of the universe? One of the things that people have commonly through time wanted to think is that there must be a center. Maybe the Earth was the center of the universe. That was a thought process before we really understood that we went around the sun. Similarly, in cosmology, one way to look out into the universe is to feel that there must be a center, because in all directions it looks like we have some homogeny to the way that the galaxies are laid out. But every single planet with a little earthling on it or another species on it would be looking out and thinking the same thing. There is no center to the universe. Everything is a part of the exact same extremely large structure. We're on the surface of a balloon. The Big Bang is when the balloon started to blow up. And then as it did, everything started to expand out. The space that you're in right now came from that same moment. We live on the outside of the balloon, though. The outside of a balloon has no center. It's a surface that is surrounding a material. It's uniform for everyone in each direction. Frank Sizzle asks, how do we know the shape of our galaxy? No one's been outside to take a look. The image behind me shows you what we think the galaxy probably looks like, and that's based on observations that we have done from Earth. And then we can look beyond our galaxy and start to see the shapes that they have and infer based on what we see, we likely have a shape akin to a spiral. Our best estimates, the galaxy is 150,000, 200,000 light years across, but then only like 1,000 light years thick. It's compact. Are we definitely a spiral? There's no definites on this, but observational evidence from looking at the way the stars move and how gas and dust clumps indicates that we're a spiral galaxy. At Regastriga asks, what are the different types of stars? Size and temperature really differentiate them. So the highest mass stars, called O stars or B stars, and then there's A stars, which are medium-sized stars, and then there's stars like our sun, an F or a G star or even a K star. Then it starts to get into the low mass stars, and those are the M stars. And then you enter a regime where you're not even talking about a star anymore, but it probably forms in a similar way. Some people call them failed stars. They're objects that don't have enough mass to get hydrogen burning at their core, to get a nuclear engine going. And we call those things brown dwarfs. And they get the letters L, T, and Y. Hanny Zizo 58 asks, are super Earths real? Super Earths are real, but I think they sound more exciting than what they are. A super Earth is a planet that is bigger than the Earth is. Sometimes they're also called mini Neptunes, which probably doesn't sound quite as exciting as super Earths. A super Earth will be about twice the radius of the Earth, and you can fit probably 2 to 10 Earths inside of it. And as we've scanned the cosmos, the most common kind of planet that we've been finding has been this super Earth-sized planet. And it's intriguing that we don't have one in our solar system. And astronomers never like to feel like our solar system is special in some way. So either we lost our super Earth, or there is some concept that there's a 9th planet beyond Pluto. Just Your Boy T asks, why is the night sky dark? The short answer is because the universe is kind of infinite. This question is also something called Olber's paradox. If every line of sight that you can point your finger at in the sky lands on a star, why isn't the night sky endlessly filled with light? So while nearby stars you can see really well, as you get farther and farther and farther away, the light It just takes longer to reach us from those locations. And at some level, it gets shifted to a wavelength that we can't see. Bring a telescope in, then you can see more. So for instance, the Hubble Space Telescope famously took an image where it stared at a seemingly dark patch of sky continuously for several days, and it was filled with galaxies, lots and lots of galaxies. But that kind of ability to see is not within the human capacity. We are just not that sensitive to light. Here's a question from Cora. How many stars are visible from Earth? So if you're in the northern hemisphere, you've got maybe 4,000, 5,000 stars available to you from the southern hemisphere. So maybe like 9,000, 10,000 stars in total that the best conditions on planet Earth, best eyeballs that we can possibly put out there could actually see. So what we can bring up here is a small sample of roughly 350,000 stars that we have mapped, that we know where they are and how they're moving. You can't see them because your eye is just not sensitive enough to be able to see these stars. Light pollution is making it more difficult for you to see them. Your eye makes it difficult for you to see. I would just encourage everybody to try and preserve their nighttime sky. This is the best view that you're ever gonna get of what's out there in the cosmos. So those are all the questions for today. Thanks for watching Cosmology Support.